Okay, good morning. We are going to be going over systems of equations by elimination. So first, I'm going to show you and kind of model why I personally find elimination to be one of the easier methods. And then I'm going to start with using substitution and then showing you how elimination really works or why I personally prefer it. So we have x minus 3y is equal to 7, and 3x plus 3y is equal to 9. So we do not, at this moment, have a particular equation that says y equals or x equals. So that means I'm going to manipulate, I'm going to change, I'm going to modify this particular equation to say y equals. Okay, so you could do x minus 3y is equal to 7 and change that to say y equals by subtracting x on both sides, getting us negative 3y is equal to 7 minus x, and then the opposite of multiplying is dividing. So dividing by negative 3 on both sides. And as you see, we're going to end up having fractions because these do not divide evenly. Okay, so I'm just going to stop there. We could also do 3x plus 3y is equal to 9 and solve for y by subtracting 3x, subtracting 3x. 3y is equal to negative 3x plus 9, dividing by 3, dividing by 3. Negative 3 divided by 3 is negative 1. 9 divided by 3 is a positive 3. And so there I solve for y, I can plug it into the equation, right? However, I mean, you can do that. That is perfectly acceptable. That is perfectly okay. However, I'm also going to show you a process or another method called elimination. So let me rewrite this. We have x minus 3y is equal to 7, and 3x plus 3y is equal to 9. So something that I noticed right off the bat is that I have a negative 3y and a positive 3y. So those coefficients, which coefficient is just a word, a term, a vocabulary word for the number in front of the variable. So my coefficients are the same. I mean, well, kind of opposites from each other, but we have a 3 and a 3. One's negative, one's positive. So there's a shortcut we can take on using the elimination method. So if I was to add these together, and again, I know adding works because I have a negative 3 and a positive 3, that is going to create what we know as a zero pair or eliminate those particular variables, right? So if I go about it that particular way and I add them, I'm going to do 1x plus 3, which gives me 4x. Those are now eliminated. And then I have 9 or 7 plus 9, which is equal to 16. And then I just continue to solve like I usually would, which is dividing by 4, and x is equal to 4. Okay, pretty easy, pretty simple. And then I'm going to take this particular x value to find my y. Let's just go ahead and use the top equation. So it was x, which is now 4, minus 3y is equal to 7. Subtract 4 on both sides. We get negative 3y is equal to 3. 7 minus 4 is 3. Divide by negative 3. Divide by negative 3. My answer is negative 1. So my solution then is 4, negative 1. Okay, now to me, I prefer elimination over substitution just because I would have to solve for a variable and plug the variable back in, but I can see, oh, I can eliminate the particular coefficients by adding. Okay, so let's use that method to solve 3 more examples, okay? So we have number 2. So this time I noticed that my coefficients that are the same are, again, it was the x values. We have 6x and 6x. Okay, those are the same, but be very careful. Adding is not going to work. So you can figure out whether adding or subtracting works by doing a little math on the side. So if I was to take 6 plus 6, I'm going to get 12. If I was to subtract them, 6 minus 6, I end up getting 0. So subtraction is the operation that I want to use. Okay, so I'm going to subtract those particular variables. 6x minus 6x, that eliminates it, which is why the process is called elimination. And then I'm going to do 5 minus negative 7. So be very careful. 5 minus negative 7. Okay, that ends up giving us a positive 12. Okay, and then be very careful here again. We have 4 minus negative 20. So 4 minus negative 20 is going to end up giving you 24. And then here we just have a one step, which I divide by 12 on both sides, and y is equal to positive 2. Okay, so I found my y value. I'm going to choose one of these to find my x value. I'm going to use the top one just because negative 20, I don't necessarily want to deal with that one at the moment. And there's also a subtract 7. So I like positive numbers. Let's use the first one to find the x value. So I'm going to do 6. Plus 5. My y value, be very careful. I almost plugged 2 in for x, but y is what we got here. Is equal to 4. So then we have 6x plus 10. I can't multiply today. That's 10. Okay. If we subtract 10 on both sides, we're left with 6x is equal to negative 6. Divide by 6. And so x is equal to negative 1. So my solution is negative 1, 2. Okay. That didn't take so long with the process of elimination. Okay, let's move on to the third example. I see that I have 5x and 5x that are the same. Okay, now be careful. Are we adding or are we subtracting? So let's do some work here off to the side. If I was to do 5 plus 5, I would get 10. If I was to do 5 minus 5, I would get 0. So subtraction again is the way to go for this one. I'm going to subtract those. 5 minus 5 is 0, so that eliminates. Be very, very careful. We have negative 1 minus 2. So negative 1 minus 2 is going to give you negative 3y. And then 6 minus 3 is 3. One-step equation. We're going to divide by negative 3 on both sides. Y is equal to negative 1. Okay, so we found my y value. You're going to pick and choose the one that you want to use. I'm going to use the second one just because I see a negative here, and I'm going to try not to use as many negatives as possible. So let's do 5x. Again, be careful. We got the y value, so negative 1 needs to be substituted or replaced when y appears in the equation. Okay, so we have 5x minus 2 is equal to 3. Two-step problem. Add 2 to both sides. 5x is equal to 5. Let me scoot this up. Divide by 5. Divide by 5. X is equal to 1. Okay, so my solution for this particular pair is 1, negative 1. Okay, and let's do one more just so you can see the other operation happen as well. Okay, so here I have the two coefficients that are the same happen in the y section this time. I have a negative 5 and a positive 5. So I'm going to do some work off to the side. If I'm to do negative 5 plus 5, I end up getting 0. If I was to do negative 5 minus 5, I would get negative 10. Okay, so I know adding is the way to go for this particular method of elimination, because when I add them, those are eliminated. So when I add, I get 2 plus 4, which is 6x, is equal to negative 28 plus 4 is negative 24. This is now a one-step equation. Let me scoot this up. Divide by 6, divide by 6. X is equal to negative 12. Okay? From here, it does not equal negative 12. Negative 4. So from here, I am able to then solve for my y value. So I got x, so we're going to go, which one do I want to use? Let's do 4x plus 5y is equal to 4. So I'm going to use 4x plus 5y is equal to 4. And then whenever I see my x value, I'm going to replace it. Okay, now again, always be careful about the variable that you solve for first, because these two I solved for y, but this one I solved for x. So that means I need to replace or substitute the x value with negative 4. Okay, so what that looks like is 4 times 4 times negative 4 plus 5y is equal to 4. Okay, so then from here, we're going to do 4 times negative 4, which is negative 16, plus 5y is equal to 4. Add 16 to both sides because I'm using inverse operations. I'm trying to solve for y. So I have 5y is equal to 4 plus 16 is 20. Inverse operation of multiplying is dividing. That leaves me with y by itself. 20 divided by 5 is 4. So my final solution, my x value is negative 4. My y value was 4. Again, always be careful the order that you write them, the order that you solve them, what variable you solve them for, because if it was multiple choice, I bet you the inverse or the switch of what I'm trying to say is 4, negative 4 could be a choice if it was multiple choice on the test, to make sure that you're writing them in the correct order. But this was a systems of equations, the elimination method. Please keep in mind that if you prefer substitution, technically we are doing a little bit of substitution to find the right answer. But if you prefer substitution over elimination, you are free to use that particular method. However, I want to introduce you the second method today, and please reach out if you have any questions on the elimination method, because we will be taking it up just a little bit to the next level tomorrow and then in the days to come. So if you are having questions today, please make sure that you reach out to me and let me know. But best of luck on today's assignment. Please make sure you are showing your work so that if there are errors, well, 1, you need to show your work for credit. 2, if there are errors, I am able to point those out and help you make corrections. Best of luck, and don't forget, I'm here if you need me.